For this video, we're going to go through the basic derivative rules, the notes that we did in class. So I might split this into 1 or 2 videos to cut down on the overall length. So below in this table, we have all of the basic derivative rules that we need for Unit 2. We have the constant multiple rule, the general power rule, the derivatives of all the trig functions, adding and subtracting derivatives, the product rule, and the quotient rule. And we have something for if we have variables in the denominator. At the bottom, we have a horizontal tangent is when the derivative is equal to 0. And we have a vertical tangent, which is when the derivative is undefined, which implies that we have a rational function. We are going to just start with the guided practice in the notes. So all of these problems are layered and more contextual than us just doing a problem where it says find the derivative. So we're writing the equation of a tangent line in point slope form. So in class, we already discussed that to write the equation of a tangent line, we need 2 things. We need 1, the point on the line, and 2, we need the slope of the line. And the slope, we're going to use the derivative to find it. So for number 1, we have f of x equals 3x squared plus 4x minus 9. We want to write the equation of the tangent line when x is 1. So first, if we find f of 1, that's going to be 3 times 1 squared plus 4 times 1 minus 9, which is 7 minus 9, which is negative 2. So we have the point on the line. Next, we need the derivative because that's our slope function. And we would get 6x plus 4. And the derivative evaluated at 1 is going to be 6 plus 4. So 6 times 1 plus 4, which equals 10. So the slope is 10 and the point is negative 2. So in point slope form, we would have y minus negative 2 equals 10 times x minus 1. Honestly, you can leave it in this form because it's exactly in point slope form. We could just make this y plus 2, but we're not. For example 2, we have the function y equals 5 cosine x plus x squared minus 3x. So we would get y prime is negative 5 sine x plus 2x minus 3. The derivative when x is 0 is going to be negative 5 times 0 plus 2 times 0 minus 3. The 0 here is because the sign of 0 is 0. So that slope is negative 3. The point on the line when x is 0 is 5 times 1 because the cosine of 0 is 1 plus 0 squared minus 0. So 5 plus 0 squared minus 3 times 0 is 5. In point slope form, we would have y minus 5 equals negative 3 times x minus 0. In point slope form, we can stop here. No need to just have y minus 5 equals negative 3x. For example 3, we have y equals 2x squared minus 3x divided by 3x plus 1. This is going to be something where we have to do the quotient rule. We get y prime is, so 3x plus 1 times 4x minus 3 minus 2x squared minus 3x times 3, all divided by 3x plus 1 squared. So low d high minus high d low over low squared. Anytime that you have to find the derivative at a particular value, once you have done the derivative, there's no need to simplify if we are just trying to find a value. We can just substitute 2 into this and save ourselves some work in simplifying. If we substitute in 2 for x, 3 times 2 plus 1, that's going to be 7. 4 times 2, which is 8, minus 3 is 5 minus 2 squared is 4 times 2 is 8 minus 6 is 2. So 2 times 3 over, this is going to be 7 squared, so 49. So we end up with the slope of 35 minus 6, which is 29 over 49. So 29 over 49. This is our slope, our M. And the y coordinate that goes along with x equals 2 is, let's see, on the top we get 4 times 2 is 8 minus 6 is 2. So 2 over 2, 6 plus 1 is 7. So in point slope form, we have y minus 2/7 equals 29 over 49 times x minus 2. And for the last example with, for tangent lines, we have x squared sine x when x equals pi over 2. So if we first find the y coordinate, when x is pi over 2, the sine of pi over 2 is 1. So we would have pi over 2 squared times 1, which is pi squared over 4. Next, to do the derivative, we have to do the product rule. So that's going to be x squared times the derivative of sine x, which is cosine x, plus sine x multiplied by the derivative of x squared, which is 2x. So again, when you are just finding the derivative at a particular point, we don't necessarily need to simplify or take out GCFs and stuff. So when we substitute in pi over 2, we're going to have pi squared over 4, and the cosine of pi over 2 is 0, plus the sine of pi over 2 is 1, and so then 2 times pi over 2 is going to be just pi. So the derivative here is just pi, and the coordinate that we got was pi squared over 4. So in point slope form, we're going to have y minus pi squared over 4 equals pi times x minus pi over 2 as a final answer. Yeah, that's it. So over on this side, we have two different, so for examples 5 and 6, we are trying to find f prime of 2, given that g of 2 equals 3, g prime of 2 equals negative 2, h of 2 equals negative 1, and h of 2 equals 4. So this is f of x equals g of x divided by h of x. And to do this derivative, we're using the quotient rule, which is low d high minus high d low over the low function squared. So f prime of 2 is going to equal h of 2, which is negative 1, times g prime of 2, which is negative 2, minus g of 2, which is 3, times h prime of 2, which is 4, over h of 2 squared, which is negative 1 squared. So negative 1 squared. So that's going to be 2 minus 12, which is negative 10. For example 6, we're going to have f prime of x is, now we have to do the product rule. So we have g of x times h prime of x plus h of x times g prime of x. And so f prime of 2 is g of 2 times h prime of 2 plus h of 2 times g prime of 2. And this is going to equal, g of 2 is 3. So we have 3 times h prime of 2 is 4, plus h of 2 is negative 1, and g prime of 2 is negative 2. So 12 plus 2 is 14. So example 7 and 8 are just more theoretical problems. We're not going to worry about those. If you have questions about them, talk to me in class. I want to keep this to the mechanics of doing the product and quotient rule and other basic derivative stuff. So that's going to stop this video. In the next video, we will go over the chain rule in context.